4.4 should feel somewhat like review. You're going to be graphing these functions on a certain domain. So you're going to be using an input-output table to graph these things. So, for example, here we have a function. You put in x's and out come y's. And we're going to use the given table. And notice that they have told us to use x equals 0, 1, 4, and 5. So what we do is we use our order of operations and we plug in x equals 0 in there for x. 2 times 0 plus 1 would be 1. Then we go ahead and plug in 1. 2 times 1 plus 1 would be 2. And we finish out the table by continuing to plug in 4 and 5. We get 9 and 11. Then you come over here to your graph, and your x's go from 0, 1, 2, 3, 4, and 5. So I'm going to try to put some nice, neat hash marks there, all the way up to 5. And then we do need to go all the way up to 11 here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, and now let me go ahead and graph those points. I'm going to go over 0, up 1 for the first point. After all, this is the point 0, 1. Earlier in the chapter, we learned how to take a table of values and graph a point, 0, 1. Then I'm going to go over 1, up 2, and put a dot. And then over 4, up 9, and over 5, up 11. There's my 4 dots. Now, we are not going to connect the dots here. Listen carefully, please. We are not going to connect the dots because they did not tell us that this was continuous. They told us to go ahead and use these x values here. So that's all I'm going to use for now. All right, because they did not say that there are millions of possibilities here. They said the domain. Remember, this is called domain over here. Domain is the input and range is the output. So the domain was 0, 1, 4, and 5, and only those 4 values. So that's why we don't connect the dots. All right, let's move on. Here they're telling us the domain in set notation. They're telling us to go ahead and use -1, 0, and 3 and run those 3 numbers through the machine that's at the top of the board here, -2x minus 3. So we plug -1 in there. Let's think about this carefully. -1 times -2 is positive 2. Positive 2 minus 3 is -1. Let's plug 0 in now. I'll give you a moment to think about that. What happens when you plug 0 into this machine? What do you get out? -3 is the answer. -3 is -2 times 0 is 0. 0 minus 3 is -3. Moving on. How about 3? Plug 3 in. -6, when you plug 3 in, minus 3. Remember, there's no such thing as subtraction. It's -6 and -3 is -9. So it looks like I need to go -1, 0, 1, 2, 3 on my x-axis, and then my y-axis, the range is -1, 2, 3, 4, 5, 6, 7, 8, 9, all the way down there to -9. All right, so let me graph these. -1 would be right there. Over 0, down 3 is right there. And then the next one is over 3, down 9. Now, do I connect the dots here? The answer is no, because they told us only on this domain. This is called a limited domain. It's a discrete graph. Remember that vocabulary word from earlier in the chapter. This is called a discrete graph. It's only dots. Only dots is a discrete graph. A little bit of vocabulary. All right, let's move on. Well, what's different about this problem? We have a function, we have a t-chart that we're going to fill in. Look over here. It doesn't say on domain 0, 1, 2 or some other numbers. It says on all real numbers. So that's what's different there. So what do you use over here? What on earth do you use if it says all real numbers? Well, you use enough to get a nice picture of the graph. So this is where I would use these 5 points here to get yourself going a little bit. Now later on we're going to learn that this is definitely linear, so we would only need 2 dots actually to get this graph, but for now we don't really know that too well. So let's go ahead and get 5 dots. So let's run these numbers through the machine. If we plug 2 through the machine, we get 2 times 2 is 4. 4 minus 3 is 1. Run 1 through, get -1, 0, we get -3. -1 goes through, you get -5. and then -7. All right, let's go ahead and graph these. Looks like I got to go down 7 at some point. I'm looking at the range here. 2, 3. And I'm going to go over 1, over 2, back 1, back 2 also. So let's fill in all of our dots in blue here. I'm going to zoom in just to help you out see it a little bit better, and so that I can be more accurate. Over 2, up 1 is the first dot. Over 1, down 1. Over 0, down 3. Look at that. They're in a line, which does not surprise me. That's the way it should be on this particular problem. -2, -7. Okay, so do we connect the dots here? Well, remember what was different here? This was on the domain all real numbers, which means we just picked these numbers out of thin air just to get a feel for the function, to see what it looks like. So yes, indeed, there are millions of more dots. We just didn't figure them out, but they do exist. They're all in here. So that is why this picture needs to be continuous. This graph needs to show that this blue machine up here spits out millions of numbers when you plug in millions of inputs. So that's why we draw a continuous graph. That's an important concept to understand. So rewind and listen to that again if you missed it. It's important to understand why this is connected and why the other one is not. All right, let's move forward. Let's do one more example with a domain of all real numbers. It says start by making a t-chart, and you choose. You get to choose because anything can go into this guy. Anything. So we're going to pick some numbers. So what numbers do we normally pick? Hopefully you're thinking 2, 1, 0, -1, and -2 should paint a very nice picture of this graph. In this case, this is going to be a line again, but it'll take a little bit longer in Algebra 1 until you begin to really recognize those. So 2 goes in, 7 comes out. 2 plus 5 is 7. 6 comes out. 5, 4, and 3. And you see the pattern there. As the x's are going down by 1, the y's are also going down by 1. And we're going to talk about that in the next chapter. All right, let me go ahead and graph these 2. And then I got to go up 7. 1, 2, 3, 4, 5, 6, 7. I do my best to try to space those hash marks out evenly, because otherwise my graph will not look very good. Over 2, up 7. Over 1, up 6. 5, 4, 3. You see that this is a line that's like an uphill line. If you're reading from left to right, you're going up a hill. And do we connect the dots here? Well, you look at the domain and it says, hey, anything can plug in. I just chose to do these 5. So I could have chosen 5 other dots. So the graph is indeed connected. And you put arrows on the ends to show that it goes on forever and ever in both directions, both the x and the y direction. And that really is all there is to section 4.4. You learned how to graph a function that is discrete. That's when they give you the domain and you're limited to those dots. Or graphing it on all real numbers. That's when you pick a few dots, you pick a few x values, run them through the machine and get a feel for what the picture looks like. And then you draw a continuous graph there, a connected graph, because the domain was all real numbers. Domain, remember, is inputs and range is outputs. All right, good luck on your homework. I believe that finishes up, or at least close to finishing up, Chapter 4. Good luck.